Okay, so what we're looking at is being able to factorise an expression. Now, this is a very important topic. The whole brackets thing is a very important topic, and the understanding of what that leads to and how to use keying in the future is very important, because I've literally just been solving problems with my year 13s in calculus and integral functions and things, and part of it was solve this equation, and the only way to solve it is through factorising. Okay, and it's the principle of it, which we're not going to go into with you today, but factorisation is when you convert an expression into two factors. So you understand what factors are, yeah? So what are factors? Sushi?
Factors are like what you get when you divide a number. Like
Yeah, okay, you can say it like that. And another way?
It's just like finding the times tables in that number. So for example, 9, it would be 3, 1, and 9.
Okay, so if you find factors, you find numbers that multiply to make the number you're looking for. Okay, so the factors of 9, you would say, are 1 times 9 and 3 times 3. So the actual factors are 1, 3, and 9. Now, this process here was factorising to find the factors. Yeah?
Do they always have to be whole numbers?
Yes. Right? But actually, when we get to algebra, it's not even numbers necessarily. Okay. Now, the reason why this works, right, there's a very important thing that you will lead on to, and I'm just going to mention it now so you kind of have an idea of where we're going, is that when we have an expression, so for instance, we have A times B, so I've got a factorised expression, so I've got two things that multiply. If I know that that equals 0, okay, now that equaling 0, that's a very important thing to be able to calculate in your maths with graphs, and when we get to differential calculus in years 12 and 13 and so on, we need to be able to solve when things are 0. Now that's very easy when you have it in factorised form, because if I know something times something is 0, I now know something else, which is what?
Well, could be 0 divided by something.
Where's the divide?
Oh no.
Hang on.
One of the numbers is 0?
One of the numbers has to be 0. Yeah? Because the only way to get the answer 0 in a multiplication is when one of them is 0. Okay? So either A equals 0 or B equals 0. So that is not really at the level we're working on, but it gives you an idea as to why we want to factorise. So factorisation is the opposite of what you've been doing of expanding brackets, but the reason why we might want to put it back is for this purpose. Make sense? Okay. So what we have to do, so if I said to you factorise something like 4x plus 8, right? There's no equals 0, we're not at that stage yet. But if I said to you factorise 4x plus 8, what we're looking for, okay, we need to find the common factors, okay, in 4x and 8. Because do you remember when we expanded, whichever method you used, if you used the box method, right? So if I just remind us, if we had the box and it's split, okay? Basically, we want something there, something here, and something here, because we then end up with 4x and plus 8. So it's like the opposite. and we've got to figure out what goes in the spaces on the outside of the book. Right. So what we're actually looking for, common factors, but a lot of the times we are actually going to look for the HCF. Now, do you remember what the HCF is? Is it the highest common factor? Because we all, at the moment, when we factorise, we try and take the highest factor out. You don't always need to do that. That's not always necessary, but this is where we start from. So we look at something times something gives 4x, but the same thing times something else gives 8. So actually, the important one is this. Stop shouting out. Okay. So we're looking for this common factor that when I multiply that one by each one of these, I get 4x and 8. So is there anything that multiplies? Tatiana? It's 4. Because 4 times what gives you x? 4x, sorry. 4 times x. And 4 times what gives you plus 8? 2. Plus 2. Okay. Now, it could have also been 4x plus 8. We could have also had what? Here. Here.
2x and 2.
Right, let's just check. 2x here, yeah? Multiplied by 2. Oh, well, let's just do what Kean said. He wanted 2x there multiplied by 2. That gives me 4x. But what's the problem here?
Yeah, because 2x is going to do something else.
Yeah, no, exactly. But I'm glad you said it that way, because I want you to realise that a lot of you said no straight away, which is great, you realise. But 2x times something, well, that would have an x there, and therefore you can't do it that way round. So, actually, we could have taken a 2 out and a 2x. Now that works because then this would have been a plus 4. Now, the way I would then write these two things out is, using brackets again, it would have been 4 times x plus 2. This would have been 2 times 2x plus 4. Now they're both correct unless I ask for this. Fully factorised. So this one is fully factorised because we took the HCF. This one is factorised, but it's not fully factorised. Do you understand the difference? Because I could still take another factor of 2 out. There's a difference between factorise and fully factorise. Now this word fully factorise obviously doesn't apply to just numbers, does it? Because if I said to you fully factorise 36, doesn't make any sense. It's just a list of factors. Which one is fully factorised? But when you've got algebra, okay, you can fully factorise or just partly factorise. Make sense? Well, any questions on that? Daniel, have you got a question?
No, I was going to ask, the first one's the fully.
So, yeah, the first one is the fully factorised one here. They're both the same. They both... Now, I just want to let you know as well that they're not different. So, I can say that 4x plus 8, do you remember we talked about how you can use the equal sign? Does equal 4x plus 2 does equal 2. They are all equal, yeah? So I've not broken any rules. They're all the same thing, just written in slightly different ways. Okay? This way is expanded. Okay? This way is fully factorised. This is just factorised. Okay? Is it?
So what makes something factorized? Like how would you recognize it?
Because it's got brackets with algebra, so it's something times something else. So this is 4 times x plus 2. So this is the a times b. This is 2 times 2x plus 4. So this would be the A times B. Yeah? Sushi, you had a question?
Another thing, if the sum is 4x plus 8, then how do we know that 4x and 8 will have a common factor?
Because 4x is, I'll do it up here, 4x is 4 times x, and 8 is 4 times 2. So we take the common factor of 4 out, okay, and put it there.
So what if it was 5x plus 8?
Okay, if it was 5x plus 8, alright? So if I said to you, sorry, I've gone a bit, I will go back if you want to, in a sec. What if I said to you, factorise 5x plus 8? Archie?
You can't do it, you have to do it the same.
Yeah. Well, it's just not possible to factorise. Sometimes it's not possible to factorise. Okay?
So you just write not possible?
True, but not possible. Can't factorise. Yeah. Sushi?
So in this expanded form, if we take a look at the factorized form, 2x.
Okay. What? Just one more example then. If I said to you, we've got 2x squared minus, sorry, I'm going to change that, 2xy. So if I said to you, fully factorise 2x squared minus 2xy, put your hand up if you know how to do that. So put your pen down if you're still writing because you've got a chance. Put your hand up if you know how to do that, you think. Does that mean the rest of you don't know how you would do it at all? The hand up, you've got no idea whatsoever. Right? No idea whatsoever. There's a lot of people with hands up for everything. Okay? Okay, so for the benefit then, whoever tells me the answer, you know there are people in here that have no idea. Therefore, you have to explain fully. Archie?
Okay, so since it's 2x squared minus 2xy,
Yeah.
since 2x occurs twice, you would put it 2x on the outside, so you times it by 2x.
Yeah.
On the inside, in the brackets, you put x minus y. So then you times both of them by 2x, which would make 2x squared over 2 and minus 2xy.
So what I'm looking for is the common factor. Now he said you can see factors. I'm going to factorise. Maybe if I do it this way, if I split it into 2 parts. Okay, so the minus goes with that side. If I split it into 2 parts, now I'm going to factorise each bit separately and try and find the common factor. Okay. Now I can see straight away, just from looking, that there is a 2 in both bits, and there is an x in both bits. So I'm going to say, well, 2x squared is 2x times x. Happy with that?
Yeah.
And on this side, we've got a 2x times y. Yeah, so we've got a negative.
What is negative?
There's a minus in the middle.
Oh, yeah, of course.
Yeah. Now, what I can do then is this, the 2x, is the highest common factor. Because there's nothing else. The x and the y are different. There's nothing else common. So what you do with the highest common factor, you take it outside the brackets and you write it once. And what's left, you write in the brackets.
Oh, okay.
Okay.
That makes it simpler.
Makes it simple.
That was way simpler than what he said.
No, it's basically what he said. It is what he said. But you were going, Archie's talking, I'm not going to listen. At the end, I just want to go, what? Whether you do or not.
It was easy.
That's a harder one. Let's have a go.
Something like this.
Let's have a go with this one. So we'll one more. So while you're writing that one, I'll write this one. So let's do going to do fully factorise 4x squared plus 4x.
Oh.
Okay, have a go at that one.
Brackets x
Okay,
squared.
right. This has dragged out the problem that I expected it to drag out, Sushi, which is you've all been flummoxed by the number 1. Okay? Because none of you think of 1 as a factor. In fact, 1 is always a factor. Okay? So, for instance, if we were to do this one, we know if we factorise, this would be 4x times x, which you all did, but you forgot that this would be 4x times 1. So the highest common factor is 4x, so we would have 4x times x plus 1. Because we've got the plus.
So it always has to be times something.
Has to be times something. If the highest common factor is what's there, you can see it, you have to leave the 1 behind. Okay? So those of you that are used, which is all of you, used to just ignoring 1 and the thing itself as factors, you can't do that anymore. Make sense? Okay. One final one from me. One final one from me.
Yes, okay. No, don't.
Fully factorised.
Oh, 3x.
3x, what? Yes. Whoa.
No.
Yes.
Oh no. It's not that bad, you think?
Okay.
No, it's y squared.
Oh my god.
Go for it.
What?
Whoa.
No.
Whoever this is like.
If you haven't got an answer for me like that, you're doing something wrong.
What? Like what?
Like this?
Like that? You could just.
Like that. Like immediately. There should be an immediate answer. Might have taken you a couple of seconds to think it through. There should be an immediate answer. Makes you think. Izzy? Pardon? Why not?
Because 3 and 8 on.
Okay, well here's the thing. First of all, you look at the numbers. 3, 2, 8, 4. Is there any common factor in 3, 8, 2, 4? If it was 2, 8, 4, yes. Common factor. You guys are smart enough with your multiplication tables and all that to know what the factors of 2, 8 and 4 would be. That would be 2. God, that was a bit worrying. But you also know that 3 is not 2. Therefore, there is no common factor in 3, 2, 8 and 4. So we can't take a number out. Then we look at it and go, well, what about the x's and y's? Yes, there's an x, there's an x, there's an x, there's... No. Then we look at the y's and go, yes, there's a y, there's a y, there's a y, there's a... No. So there are no common numbers, there are no common x's, and there are no common y's. Therefore, by adding the 4 on the end, I have made it impossible to factorise. So the answer to this would be, it can't be. But what I'll get you to do now is what you were doing, which is let's get rid of that 4 and make it possible. Now it's possible, but you should already have realised that will there be a number outside the brackets? No, because there's no common factor in the numbers. So we would still do 3 times something plus 2 times something plus 8 times... That has to stay in the brackets. Okay. Pardon? Yeah, we can keep going now. Then we look. I'm doing it kind of the quick way now. Are there x's in all of them?
Yes.
Alright, how many x's can I take out of all of them, but it's got to be the same of each time? So that means we can only take the lowest amount of x's. So come in. 1. Which one forces that to happen? The middle bit only has one x. Therefore I can take that x out It gets rid of 1 there, and it gets rid of 1 there. But I can't take any more because this one no longer has an x in it. Okay, so this is what happens when we're dividing through. Now, what about y's? Sushi?
1y.
1y, because I can take that y. Okay, so actually before I do that, I need to write down what x's are left. So that still has 1x. This one has no x's. This one still has 2 x's. Now I take a y out, so that one's finished. That one's dealt with. Okay. This one has 1 gone, so it leaves it with 1. This one has 1 gone, so it leaves it with 1. Okay? That's fully factorized. You get it right?
Yeah.
I got the tiny number. I already do that, right? I always do that.
Okay. Yeah. Well, can I get you now, guys? So in your books, have you got the there? You haven't. Okay. Let me write out a couple. Right. So I'm just going to write out a couple for you, just in case you then watch this and want to practice more. This is the exercises on page 136, 137. Okay, so I'll just write a few out and you can just do them. Okay. Okay, guys. So there you have some. Be aware, this one is: are the following fully factorized? It's just an answer, yes or no. If it's a no, give the fully factorized form. Okay.